Okay, private bank Kleinert, a private wealth manager in Munich, has a number of clients with large holdings in the German fintech firm Sparcoin. Kleinert's analyst is concerned about a drop in Sparcoin's share price in the next year and is recommending to clients they consider purchasing a one-year put with an exercise price of 100. Sparcoin's spot price is 105.25 and it pays no dividends. Risk-free rate is 0.37%. Kleinert's analysts estimate a 50-50 chance that the price of Sparcoin will either increase by 12% or decline by 10% at the put option's expiration date. Which of the following statements best describes the no arbitrage option price implied by this assumption? We're just going to ignore this. We want the no arbitrage option price. We have RU, which is 1.12. We have RD, which is 1.10. We have 1 plus R, we're told 0.37, 0.0037. So we can calculate risk neutral probability instead of using these. 1 plus R minus RD over the full range. We already have these. Oh, I said 110 here, sorry. It's 10%, 0.9. Good call. There we go. We'll get 0.4713. That's the probability of an up move. 1 minus pi is the probability of a down move. We're going to need a value for the put on an up move and a value for a put on the down move. If it goes up 12%, take 1.0525 multiplied by 1.12. It's going to be higher than the exercise price, so we know that the PU put on the upside is going to have a value of 0. Take 105.25 multiplied by 0.9. It will be in the money. Subtract that amount from 100 and we get 5.275. Being that the up move has 0% probability, we can ignore pi. It is just 1 minus pi times the price of the option. This is 0.4713. It's 1 minus 0.4713. And then discounted back at the risk-free rate, we get 278. Let's see if we can eliminate some of these. Since there's a 50% chance that the stock will fall to 94.73, there's a 50-50 chance of a 527 payout upon exercise, and the no arbitrage put is therefore worth 264. No, it's not. This is just meant to throw you off here. Since there's a 50% chance that the stock will fall to 94.73, there is a 50-50 chance of a 527 payout upon exercise, and given the risk-neutral probability of 0.47, that is the risk-neutral probability, the no arbitrage put price is 248, arrived at by taking the put price multiplied by the probability of an up move. Not an up move, probability of a down move. 527 times 1 minus 0.47, and then you take the present value of that. We have to go with C. If Kleinert's clients observe that the one-year put option with a €100 exercise price is trading at 250, remember we had just calculated at 278, so this is cheap. Which of the following statements best describes how Kleinert's clients could take advantage of this to earn a risk-free return greater than 0.37% over the year? And recalling put-call parity, the stock plus the put equals the call plus the present value of the strike price. At 278, both sides would be equal. At 250, the stock plus the put would be less. And rule of arbitrage, buy low, sell high. So we'll buy the low side. We're going to buy the put, and we're going to buy the stock. But we can't just buy the stock. We're going to have to figure out in what proportion we buy it. We need a hedge ratio. So we'll calculate H. Remember, we did this on the previous screen. The put after an up move had a value of 0. The put on a down move had a value of 5.275. So there's 0 minus 0.5275. And then this is SU minus SD. So it's 105.25, 12% higher, 105.25, 10% lower. You get negative 0.2278. The negative sign should not surprise you. Remember, puts have negative delta. Okay, let's begin. Kleinert should purchase the put option, yes, and also purchase approximately 0.23 shares per option to match the hedge ratio. Yes, that's exactly it. Remember, we're trying to get to a delta equal to 0, right? That is a risk-free portfolio. If we buy the put, we're going to get negative 0.2278 delta. If we buy 0.23, actually they just rounded it off, but we'll just say 0.22. If we buy 0.22 0.278 shares, we will get plus 0.2278 delta. Negative delta, positive delta, we got delta of 0. So yes, for A. Let's get rid of the other two. Kleinert should purchase the put option, yes, and purchase 50%. No, of the underlying shares given the 50-50 chance. This is using subjective probabilities. We can just ignore that. Kleinert should purchase the put option, yes, and purchase 47%. That is using the probability of an up move and not the hedge ratio, which is what we need initially to set up a risk-free portfolio. Get rid of that. A. If risk-free investments yielded a higher return over the next year, in other words, what they're saying is that the risk-free rate, what if the risk-free rate were higher? Which of the following statements best describes how this would affect the no arbitrage value of the put option on Sparcoin shares? Well, we already know the put should be lower. We can go with that, but we want to know why the put should be lower. Let's do it here. Here is the risk-neutral probability of an up move. Notice it's 1 plus R minus RD. So if you have a higher R, you're going to have a higher probability here because the numerator will simply be larger. You're increasing the spread between the forward price and the lower bound. A higher R is a higher probability of an up move. If you have a higher probability of an up move, you must have a lower probability of a down move. The value of the put is as follows. Notice that here's the probability of a down move. Remember, this was 0, so it doesn't matter how large this value gets because this was 0. It only matters what this value is. You're going to have a lower value here, so you're going to have a lower numerator. You're going to have a higher value here, so you're going to have a higher denominator. Lower numerator along with a higher denominator must lead to a lower price. An increase in the risk-free rate will have no effect on Sparcoin's put option. Get rid of that. An increase in the risk-free rate will increase the value of the put option. Get rid of that. An increase in the risk-free rate will decrease the value of the put option as it will both increase the risk-neutral probability of a price increase, we said that, which lowers the 1 minus pi, and decrease the present value of the expected option payoff, decreases the present value because you're raising R in the denominator, which is your discount rate to bring your numerator back to times 0. If the expected percentage increase and decrease in Sparcoin share price were to double, in other words, we're doubling the volatility, which of the following is closest to the estimate of the 1-year put option price with an exercise price of €100? Remember, originally we had RU of 1.12 and RD of 0.9. So this will go to 1.24. This goes to 0.8. Let us calculate, to get to a put price, we know it is the probability weighted expected outcomes discounted back. We're going to need to calculate pi because this is our missing variable here. 1 plus R minus RD, R over RU minus RD. Well, risk-free rate was 0.37. Our new RD is 0.8. Over 1.24 minus 0.8, we get 0.46295. We need a PD because it's 80% to the downside now. So there's our strike price minus wherever. This will be ST, which is SD. ST meaning at this point in time on a downward move. SD. You can use either notation. 105.25 times 0.8, you'll get 1580. Clearly, if we're at 105.25 and the strike is 100, anything we raise it by, there's no point in calculating 105.25 times 1.24 because 105.25 is already out of the money on the put, or the put is already out of the money with 105.25. So anything higher will still equal 0. So 0 plus 1 minus pi, we've already calculated pi as 0.46295. 1 minus 0.46295 times the value of the put, discounted back, we get 8.45. Closest one here is 850. I looked at the answer. It's because they do this, 0.46. They just ignore the 0.295, and they get to 850. So if you rounded off to 0.46, you would have gotten to the same answer. I tend to keep all the decimal places. Clearly it's not 790. Clearly it's not 740. I'm at 845. I could just say, well, I preserved my decimal places, so even in the exam, I won't know where they're rounding off, so I'll preserve my decimal places, and it won't be ambiguous. It won't be like there'll be one for 850 and one for 844. where you have to say, well, now what do? I have to guess at where they rounded off. It won't be ambiguous. It'll be fairly clear.